I have to admit something to all of you. I've had a serious mental block for a while, and it's centered around this patent application and the people behind it. And I don't want to be frantic or overly emotional, but it has taken a serious toll on my ability to think about other things and be creative. And being creative is an essential part to ending lead poisoning. Now, I think that this is the last time I'll have to do this. We've gotten so far into the weeds with this application. It's taken literally years. You can see that it started out in really 2021, but since 2022, it's been prosecuted. And now we are so late in the game where all of these things have happened. And I'm exhausted. I'm exhausted by the notion that there's people out there who are actively working against me in their own self-interest. Literally, and this is kind of funny, approximately 1 part per billion of the human population is actively hoping, most likely, that I can no longer sell fluorospec, that I have to give them millions of euros. And that's evidenced by this, well, this is only one page of a 36-page complaint. One of them's in this nice thick packet of paper. And the complaint is in the Netherlands, and it will be addressed after this. But that is going to be a lot easier to address than this, for the simple reason that the applicants have been communicating directly with an examiner who seems to be liable to being misled about certain things. I'm going to break down the validity of the patent application right now. And it's going to be really obvious that this is not going to get patented, which is actually to the benefit of everybody who's not part of that one PPB. So 999,999,099 or whatever. I think I forgot some nines there. Parts per billion of the human population stands to benefit from this, for the simple reason that monopolies are only good for the people who control the monopoly. That's a fact. So let's get into this. I'm going to try to keep this kind of short. So we'll clip that on there. Excuse me. That was a bit rude of me. But this is kind of a rude situation. So let's look at my actual complaint here. So the patent, first of all, centers around the detection of lead on a solid substrate using a methylammonium or any kind of, we'll just read the claims, right? Method for detecting of the presence of lead on a solid substrate suspected of containing lead, comprising the steps of contacting the solid substrate, suspected of containing lead with a reagent composition comprising a liquid medium and a halide reagent capable of reacting with lead to form a halide pervoskite. The solid substrate being selected from painted surfaces, glass, metals, and plastics. And subjecting the solid substrate to a light source that is shorter than the emission wavelength of the perovskite. And so a good example of this is right here. Now, this isn't perovskite, but it is clearly fluorescent. And the interesting thing about fluorescent materials is that they reflect invisible light when you're exciting them with ultraviolet light, which is what's in this flashlight. I don't know what happened to my vision there after that. I don't know, maybe it's the screen. Anyway, leave a comment if the screen has changed. So, and the second claim is saying it's carried out in situ, and then the third claim is saying that the solid substrate is painted surfaces. The fourth one is claiming that The solid substrate is carried out when they put droplets of the reagent onto the surface. The fifth one is spraying. The sixth one is wiping. So not a lot added to the application by these three. The seventh is saying that it's prepared from these different materials, and they highlight isopropanol, and that will be important in a moment. Number 8 is saying that there's a combination, or particularly that bromide is ideal. Number 9, saying that the method is using some of these other elements that would be, not methylammonium, as was not claimed so far, it looks like, actually. Oh, sorry, yes. In here is the methylammonium. And so methylammonium bromide is going to be used, and isopropanol is the medium. And so we'll see that. That'll be important soon. So number 10 is saying that the preceding claims, the halide reagent, is selected from methylammonium or foreign or cesium. So cesium bromide, methylammonium bromide, or foreign I don't know how to say that one, bromide. They all work. And they're all green, thanks to the bromine. Number 11, according to any one of these preceding claims, wherein the sample is contacted with an oxidizing agent prior to contacting with the halide reagent. And so let's take a look, now that we know about the claims, at some of the pre-existing artwork. So we can see that there is, did I X out of it? I'm so sorry. Just give me one moment. So this paper was, and pardon my redaction of it, this paper was published about 4 months before the application that I'm referring to was published. So it says that highly fluorescent methylammonium lead bromide pervoskite could in situ grow in a sulfahedral functionalized mesoporous alumina film when methylammonium bromide meets the sulfahedral captured lead, and that means that you can get a fluorescent compound. So you can see here that under UV illumination there's a glowing, and you can see that, right? And we can look at the steps where you have this mesoporous alumina, which is just a tiny holes in the alumina. 20 nanometers is so small. This is microscopic. And they actually found that you can't get any lead to stick to the surface until you add something called MPTS. And this is something that I've worked with. It smells like sulfur, and it makes me feel sick. I did this experiment several years ago in my kitchen. That was regrettable. But I was able to replicate it, and it is pretty interesting because it has the distinct ability to latch onto lead. And so you can see here that the functionalization of the surface basically is composed of these sulfahedral bonds attaching to the surface. And then we have lead, right, being captured. And then we have lead being converted with methylammonium bromide into a perovskite, which can be seen. However, it's not immediate. In this circumstance, the methylammonium bromide did not show itself until there was a evaporation. So you can see they used an oven here at 60 degrees Celsius to evaporate the solution, and you see that they dripped it onto the surface. And so once they dripped it, they could see that the low formation energy of methylammonium lead bromide allowed the rapid crystallization of perovskite nanocrystals on the skeleton or in the holes of the mesoporous alumina as soon as the solvent was evaporated. Then the film was placed in a quartz cuvette for photoluminescent measurement. But they could see it with their very own eyes, and you can see that by the photos here. So this is a pretty complicated step, but it essentially converts the lead in situ, because the lead is here, right, captured, and then it's converted. So this is the actual operative step that's germane to the patent application and what I'm talking about today. Now the lead was in the water initially, of course, but it was not converted until it was on a solid substrate. And it was chemically bound, as we can see here. It's clearly bound to the sulfahedral moiety, and that's not a weak bond at all. So, why does this completely undercut the patent? You would say this is completely different. Well, the skilled practitioner would certainly research other things, and one of them would be this. In the application, which I could bring up, the applicants themselves admit it is noted that the photoluminescent properties of lead halide perovskites are known in the art. This material is under development for use in, amongst other applications, solar cells. So we can look directly at this 2018 paper, which is years prior to the application, and it is participated in by two members of Lumetallix, who are the two named inventors. So these folks essentially took a calcium carbonate surface, they added lead to it, and then they reacted it to form the perovskite. And so we can see that is the case here. And it was pretty cool research. They took a sand dollar, they took a cuttlefish bone, and then they had synthesized these tiny nanocrystals. And now these are not nearly as small as those mesopores from the Wang et al. Paper. You can see that these are only 20 nanometers in diameter, whereas these are much larger. So this is 5 micrometers, is this little thing here, and much larger. You wouldn't barely even be able to see the nanopores. That's how small they actually are. So let's look at this. This sand dollar contains lead. It contains lead carbonate, and just like lead naturally diffuses into our bones, lead will naturally diffuse into any carbonate structure. So we start off here with the lead carbonate. They drip something onto it, and it starts to glow fluorescent green. Now, this is clearly elucidated right here. It says that time-lapse fluorescent photography under UV illumination at 365 nanometers of a sand dollar, converting in 45 seconds from lead carbonate into methylammonium lead bromide. Now, what's the reagent? Because we know that this is methylammonium lead bromide, which you would get from contacting methylammonium bromide with the surface. Luckily, they were so kind as to give us the exact recipe in this paper. So it says right here, to convert the surface of a sand dollar, a solution of 25 milligrams of methylammonium bromide in 2.5 grams of isopropanol was prepared. And please note very clearly that it says isopropanol, not an aqueous solution containing isopropanol or anything like that that would indicate that there's anything but one chemical, isopropanol, involved here. Now, they see when the conversion was reacting, it was performed under UV light. You can see the formation of the perovskite in real time. Initially, white sand dollar turns light orange in daylight and fluoresces bright green under UV irradiation. And that is, they even made a video about it. And yes, I do want to continue working because I will be submitting my final, basically, comments on the patent application at this summation of this video. And then I will more or less wash my hands of worrying about this patent application potentially interfering with my work. Oh, this was the wrong one, sorry. So we can see on Twitter that Lucas had posted a actual video of the sand dollar back here in, looks like 2018. So you can see here that this is clearly converting, and you can see that Lucas and the Neutralin lab, I don't really know how to say Wim's last name, but this is an example of that sand dollar being converted. Pretty quick, huh? So you can see the interplay between the liquid that was used in the Holtis et al. Paper and the information in the weighing paper about how you can detect scant amounts of lead captured on a surface using methylammonium bromide. What's interesting here is that they had to evaporate, right, the solvent, because DMF, or dimethylformamide, I don't know how to say it, but it's kind of toxic and I don't really like working with it. It's especially useless for detecting lead because it dissolves the pervoskite crystals. So you actually have to completely evaporate it in order to get any signal. However, isopropanol does not dissolve methylammonium lead bromide, only methylammonium bromide. So you have a situation where you can get instantaneous crystallization of perovskites that allow for the direct visualization of lead where it is on the ground, on a surface, etc. So let's go back to the third-party observation that I'm about to make. So I'm not claiming there's any prior use, but I am saying that there's a few things that are general knowledge, and this is important. So we know that historic lead-based paint contains 50 to 70% lead by weight, and it does chalk, kind of comes off in a dusty form. They actually used to say that that was advantageous because it would be easy to clean your walls because any smudges or dirt would come right off. Isn't that lovely? Lead crystal contains 24% lead oxide by weight, and that metallic lead naturally produces native oxide layers. So that's important because lead has to be in the +2 oxidation state in order to be detectable through this methodology. And that's why at the end of their patent application they wrote that it needs to be, I have so many tabs open about this, or I mean I wouldn't say it needs to be, but it may be advantageous to contact it with an oxidizing agent. So let's move right along and look at number 4, which is talking about the necessity of insoluble chemical compounds as a reaction product. So we have several. Sodium rhodisonate forms lead rhodisonate, which is insoluble. So you can see those lead rhodisonate precipitation products. Sodium sulfide also forms lead sulfide, which is insoluble in water. And potassium chromate also forms lead chromate, which is also insoluble in water. The latter two, sodium sulfide and potassium chromate, are pretty toxic, whereas sodium rhodisonate is not. That's why sodium rhodisonate became a very popular lead testing compound that I've been selling since 2019. And so, of course, they're sprayed, swabbed, or dripped. Sodium rhodisonate it's sprayed or swabbed, whereas the potassium chromate and sodium sulfide are typically dripped onto the surface. So that's just the lore surrounding lead testing that everybody knows at this point. It's not a mystery. It's not, secret information, etc. So what I'm saying essentially isn't that this was already done, what their patent application is claiming, because, of course, the Wang et al. Paper doesn't specifically restrict the substrate to painted surfaces, to anything like that. It actually sticks to what it's doing, which was just detecting lead on the mesoporous alumina surface. However, there are certain features of the prior art, meaning Wang et al., which directly reflect Claim 1. And we're going to go through those right now, and then we're going to analyze how this patent cannot possibly be granted, or at least if it is granted, it cannot possibly be enforced because the material just isn't patentable. Which is something that I told the folks over at Lumetallix several years ago when I helped them to navigate part of the regulatory landscape in the United States, namely the Controlled Substances Act, because methylammonium bromide contains methylamine bound to bromine. And methylamine, as you may know, watching Breaking Bad, is a List 1 chemical controlled by the DEA because it can be used to make illicit drugs. So D3 is Wang et al., and I will be referring it to D3 probably often. So it says that there's a solid substrate, of course, containing chemically bound lead. The reagent composition is disclosed as methylammonium bromide contained within dimethylformamide, which is capable of reacting lead. Of course, there's the pervoskite formation in situ. On the surface of that mesoporous alumina film, you get the conversion from lead that's bound to the sulfahedral moiety into methylammonium bromide, which is then fluorescent under the excitation of shortwave light. They also use 365 nanometers. There's no features of the prior art that are not disclosed other than this specific list of painted surfaces, glass, metals, and plastics. And what's important to understand is that there's no technical effect conferred by the selection of these substrates. Yes, you're able to test those substrates, but speaking technically, the invention or the purported invention merely converts the lead found on those surfaces into pervoskite so they can be detected with shortwave illumination. And I cover that here, saying that there's no unexpected technical effect. The resulting physical signal is identical to that in D3. And the applicant did assert, at one point at least, not only that the lead is bound to a variety of other compounds, but that it is encapsulated somehow. And unlike the so-called porous mesoporous alumina surface, the lead is bound within the matrix, which I find to be a hilarious misrepresentation of something that is oh so obvious to anybody who thinks about it for a few seconds. So let's do that together. So as I just said, the applicant argues that lead in the claimed substrates is chemically incorporated and unavailable, but it's actually refuted by the applicant's own description in their application. So on page 14, paragraph 2, the applicant explicitly admits that metallic lead that has been exposed to air is covered in a natural oxide layer. This oxide layer instantly reacts when contacted with the reagent. This confirms that the target analyte is actually present on the surface and isn't somehow incorporated into the matrix, since the oxide layer is specifically lead oxide, or otherwise it wouldn't react. The paint, for example, on page 13, paragraph 5, they describe the amount of lead that they actually put in their paint as 1 gram of lead white with about half a gram of linseed oil. So that's about 71% lead pigment by weight, and obviously there's going to be some lead on the surface, and this is known generally speaking because lead paint is incredibly leady, and it can be tested by a variety of chemicals, sodium rhodisnate, sodium sulfide, and potassium chromate. Furthermore, the applicant claims that the porosity of the substrate in D3, or Wang et al., is somehow allowing the reagent to access the lead more easily, and it's loosely bound or it's not bound at all. Meanwhile, it's chemically chelated, chemically reacted. The lead carbonate basic in the paint or the lead oxide in the glass or metal is oxidized in 2 out of the 3 samples, and the third is bound to a carbonate, which is much less strong than the sulfahedral bound lead found in D3. Not looking too good so far, but there's even more, if you could believe it. This patent application is so insufficient to protect this intellectual property that it really made me uncomfortable dealing with these folks, and it indicated to me that they had some kind of a blind spot, that they weren't able to think more deeply about this because they were so obsessed with the idea that they were going to be the only people selling this for the next 25 years. And wouldn't that be a shame to the 900,999,999 parts per billion of the human population. So I say that it's much easier to find lead on a grossly contaminated surface rather than finding a scant, and in the D3 Wang et al., they found only about 1/4 of a microgram of lead on a dime-sized piece of mesoporous alumina, and much of that lead was no doubt trapped inside of the mesoporous alumina, which was also functionalized with the sulfahedral bonds, which is important to understand. Those black holes seen in D3 aren't like straight tubes to the other side. No, this is a complex like tunnel system, and the lead is all throughout the sample. So you're not seeing all the lead. You're just seeing the lead that's on the surface, but that lead does go down inside and throughout the inside of the sample. I further say it's obvious that a skilled person would combine the features to determine that there's, this is obvious to use because there's, a bunch of other reagents that already detect lead, and you apply them to surfaces and they change color, and that's how you know that there's lead. Me, being somebody who's manufactured lead tests for years, knows this implicitly, and anybody who acts like they don't is being disingenuous or stupid. So basically that's it. This is specific to the European Patent Office. They say a new use of a known measure is not inventive. It exploits the same technical effect. Since the technical effect, perovskite conversion and UV excitation, is identical to D3, this is just an analogous use. The applicant claims that instant detection is an improvement over D3, which is true. Obviously, you can't dry paint samples in an oven at 120 degrees Fahrenheit to drive off the toxic solvent DMF in a home lead test. But you don't have to, because luckily, Holtis et al. Clearly provided the instructions to make the reagent. And that's the same liquid that I use in fluorospec. And the applicant may argue, well, that's a totally different field of endeavor. That's synthesizing solar cell materials, but the application clearly points that it is noted that the photoluminescent properties of lead halide perovskites are known in the art. This material is under development for use, among other applications, solar cells. And they know that because they themselves worked with it, making solar cells. Couldn't help but drop that in there. Now, this isn't even necessary because the patent examiner's manual clearly states information about neighboring technical fields and how the skilled person would search pretty far and wide to find stuff that may work when they're trying to solve the technical challenge of finding a reagent that contains methylammonium bromide that has no room in it to dissolve the methylammonium lead bromide, which would give you the immediate effect of having the crystallization. And I kind of break that down here, that they would solve the solubility and precipitation problem by consulting neighboring fields. Combining these two is obvious. The preceding capture steps of D3 are relevant because it doesn't matter that the lead came from the water. It matters that when it was converted to perovskite, it was on a solid surface. To imagine that the skilled person is so dumb to not understand that they can take part of D3 or Wang et al. And apply it to any surface is a kind of wishful thinking, to say the least. So, actually accidentally put another inventive step, but I can't get that off now. And so there's another, like the final part of this is essentially that the applicants seem to want it both ways, where they say that the lead is chemically incorporated or trapped within the closed matrices like paint or plastic, but the issue is that the reaction only takes place when lead ions are available. And so the lead ions are clearly available because they can be tested. Metal can be tested. Glass can be tested. Paint can be tested. And if there's lead in plastic or rubber, that can be tested. I think that putting rubber on there would have been a much better thing and a safe bet. It's just as safe as plastic. But the thing is, they didn't even really talk about plastic in the application, so I'm not sure where they were going with that one. But so it basically says that, they're lacking the inventive step there. So I'm saying blah, blah, blah. It's just said that. The applicant cannot argue that lead is unavailable to establish non-obviousness over D3 because D3, obviously the lead is available. That's why it reacted. But if they say, well, the lead's not available, well, how are they showing in the application that their specific project makes the lead available? When we look at their actual application, we can see pretty clearly that they test for lead on a variety of surfaces, But the lead is not trapped anywhere. See lead carbonate powder, the lead's clearly available. Lead carbonate particle film on glass, the lead is available. Same here, same here. They're just testing a chemical form of lead, lead chloride. They're testing one part of white lead-based paint here, lead acetate, another lead chemical, lead oxide, lead nitrate. Now they test this lead white paint, fresh and cured. They test metallic lead, which obviously has lead on the surface, lead glazing, which obviously has lead on the surface, lead oxide, which is a homogeneous mixture, just like the paint, of lead and something else. And there's 24% lead in this instead of 71%, but that's still an awful lot. The rubber coating of wires, a cut-apart battery, the debris from sawing the battery, solder, a few different chemicals, lead fluoride, lead bromide, lead iodide. And I actually am not even sure if lead fluoride can be tested easily, because lead fluoride is super insoluble. And this test doesn't work very well on lead chromate, which they, for some reason, didn't test. But they tested this on other materials, copper, aluminum, tin, zinc oxide, titanium oxide, glass, titanium, all these things. And there's no surprises here. And this was probably also unnecessary to the application because, everybody who does anything with perovskites knows that you don't get fluorescent perovskites when you have all these chemicals. Otherwise, people will be using them over lead to make solar cells. They tried a variety of solvents. They found that this was the best one, which is the one that they used in the Holtis et al. Paper. They tried a variety of different ratios of halides. And so they also did this, interestingly, in Holtis et al., where they had, this is methylammonium chloride mixed with the bromide. This is methylammonium iodide mixed with the bromide. And the bromide is really essential to make sure that the reaction actually progresses. There's something about the bromine in there that makes it a lot easier to do, apparently. And I've tried a bunch of combinations myself. These other chemicals, butyl ammonium iodide, phenylethylammonium iodide, different metals, no luck there with getting to not work, although iron does seem to interfere. And I'm curious about how they actually mix these, but it doesn't really say. Solution report of one mole various combinations. So it looks like they just had a very dilute mixture of lead, which it doesn't really say what kind of lead, and then they applied it to a surface. So, just a few different, things. Testing for lead in soil. It's funny that they didn't actually get some lead soil and confirm it with XRF or another method. They just made lead nitrate mixed with soil and acted like that's what lead soil is, which it's not. So they it doesn't appear that they knew very much about contamination. Sawing a battery apart obviously is going to cause contamination, but they didn't make any mention of lead-based paint dust. And I've done my own independent research, which qualified that particles as small as 50 micrometers can be detected with lead-based paint dust. It's really interesting. And what's so funny is the Wang et al. Paper, it was successful at chelating the lead out of a sample of 50 milliliters of water down to 5 ppb, which is only 250 nanograms. So what I'm plotting to do is chelate the lead onto a much smaller target, similar to a speck of dust, which I know can be visualized, thereby making trace detection possible. And this is something I actually said to these folks right off the bat. Hey, you can't patent this, but don't worry. We can sell this, but we should really team up on making trace detection with perovskites a thing that everybody uses as an alternative to ICP mass spec, ICP optical emission spectroscopy, or atomic absorption spectroscopy. Those are all expensive machines. $300,000, $200,000, and $50,000 respectively. That's an awful lot of money, but you can do trace analysis with chemicals if you're handy, which I am. So, they talk about cesium bromide, which doesn't really look, they used a slurry. It doesn't dissolve in very much. Pre-treating samples with oxidizing agents, and then, confirming the perovskite using X-ray diffraction. And this is a easy move for them because they actually used X-ray diffraction right here to ensure that they had perovskites, right? Good job. So they've applied essentially their teachings from, the work from the past to this current thing, which, it's It's always nice to use something twice, right? So anyway, that's why the patent application is totally bogus. It kind of leans into, and I'll make a subsequent video on this after I get a little further in the case that they've brought against me, which essentially says that I, shared secrets from their research with everybody whenever I said methylammonium bromide. Just one last thing, which is really interesting. I suspect that the logic behind that, the suppression of methylammonium bromide from the zeitgeist centers around the idea that not disclosing what's in the reagent serves a dual purpose. And this is just speculation on my part, but hear me out. There's a law in the United States called the Toxic Substances Control Act, and it governs what chemicals can and cannot be sold. Now, methylammonium bromide is not on the Toxic Substances Control Act inventory. And I found this out because the EPA sent me a subpoena and they said, have you been importing this? We're here to find out. And I replied honestly, as one would, to the federal government, because lying to the federal government is yet another crime. So they told me, yes, importing methylammonium bromide, selling it, manufacturing stuff with it, what have you, is a crime. And I was so shocked by this because I had no idea. I thought I had navigated the regulatory landscape by, getting a license from the DEA. And I wasn't really familiar with EPA enforcement or laws, and they're really convoluted, much less straightforward than, hey, this can be used to make drugs and therefore it's bad. So through my, communications with the EPA, I was able to get permission from the government to make up to 180 kilograms and sell it of methylammonium bromide. So I don't believe that Lumetallix has done the same thing. And what I believe is that they are engaging in a, effort to suppress the release of information about the fact that their test contains methylammonium bromide in an effort to stymie competition. Because Lumetallix, we'll just wrap it up with this because I'm just figuring this out. So Lumetallix claims that they have a patent, right? And I'm sure if you go and look at this same exact page right here, the Lumetallix LinkedIn post, and now it's January 9th, so they made this January 3rd, edited it at some point. They'll likely delete my comment. They deleted a comment earlier when I said you guys don't have a patent. Because right here, they're claiming that they have a patent. It says right here, we've received formal notification that grants our international patents for the core Lumetallix technology from the European Patent Office. Exclamation point. And then they say it bodes well for their American applications. But who are they saying this to? Perhaps investors? Their ex-lawyer told me one time that they had planned to sell the company. And I have, of course, recorded every single thing I've ever done with Lumetallix and their representatives. So, I'm not lying when I say any of these things because I don't lie. That's an easy way to be a loser, in my experience. Lying, you get caught lying, now you're known as a liar, and the lie doesn't pan out. So, best to tell the truth. Now, why would they try to hide what's in their tests if they actually say that they have a patent? And of course, they're stating right here that they think they'll even get patents in other locations. Somebody with so much confidence, why would they hide what's inside? Well, the conclusion that I'm forced to draw is the Lumetallix kit can't legally be sold in the United States. And that's why about 60 days ago, I submitted a 60-day notice to Lumetallix, to their distributor, Unobtainium Inc. in America, to Lead Safe Mama, to Chelsea Bernstein, also known as the Lead Lady, because all these people are engaging in an effort to sell the product Lumetallix. And since they've all been now notified, and I explicitly broke down the laws and how Lumetallix containing methylammonium bromide is a violation of the Toxic Substances Control Act, importation, selling it. They're all potentially moving from civil infraction to criminal infraction. I'm not a lawyer. I'm not saying that they are necessarily, but the knowledge that you're breaking the law. And I believe that it's plausible that people in America, probably not Chelsea so much as others, could claim that they don't know what's in it. And, because the Lumetallix SDS sheet doesn't have any indication that there's anything other than isopropyl alcohol in there. But isopropyl alcohol doesn't test for lead, clearly. The last thing that I want to say is I used to sell Lumetallix, and I asked them what was in it so I could certify on the Toxic Substances Control Act document, because every time you import any chemicals, you have to certify actually what's in there. So I'm importing stuff, they're shipping to me by FedEx, which was not a good idea because it was it's too much money per shipment. Should be sent by boat or should just be manufactured in country, which was something that I said from the rip, because lowering the cost of manufacturing these goods means that more tests could be given to consumers for less money. And that's clearly important for, the public health outcomes and for the individual's likelihood of purchasing the test. And if somebody doesn't purchase the test because it costs too much, I feel at least a little bit morally responsible because I am deciding the price. If I make the price too high and you don't buy it and now you or your kid get lead poisoning, isn't that on me to some degree? So I want to avoid any kind of liability, in the thereafter for being a greedy, selfish person who couldn't figure out a better way. So I opted to vertically integrate. Now I'm, waiting for my first shipment of methylamine, combine it with my hydrobromic acid. I'll be making this chemical for 20 times less than I had purchased it previously. Really going to improve, my abilities in offering a low-cost product and getting this test to as many people as possible. So what I want to say about this is it's likely that Lumetallix and friends are engaging in sort of a diffuse network of, subversion of the law at the very least, and at the very most, a, ongoing criminal conspiracy to evade U.S. chemical safety regulations, which are important. TSCA is the same authority that they regulate lead-based paint under, actually. So it's not just like a random law. It's integral to this entire thing. And I just want to point out the last point here. I sold about at least double this in the 2025 calendar year. And instead of, had I sold 10,000, I would have conferred many more tests, right? Almost, just shy of 40 million tests, about 35, give or so, million tests in theory. And that doesn't even account for the fact that, I just can't even get into it. So many discounts, double orders, all this stuff. I mean, it's been so fun for me to help so many people, I avoid lead poisoning. This all stems from my traumatic experience with Lead Safe Mama, Tamara Rubin, where I thought that the way she acted was a direct result of her kids getting exposed to lead, but I didn't realize that she had already acted like this. There's a little known fact that in 2002, when her house burned down, the company who insured the house suspected her and her husband of arson and also of lying. And Tamara and her husband claimed, amongst other things, that the house was burglarized before it was burned down or while it was burned down, according to one letter that Tamara actually wrote the police. And I'll get into all those in depth later. But I think the takeaway here is that I am really kind of a Pollyanna in terms of trusting other people and thinking that they must be at least as smart as me or smarter, because they have not made these stupid decisions that I've made, and they have better, bigger credentials than me. Lumetallix, PhDs, all these people are older. Just something about people who are older has always been you must know more than me, right? But I've been shown time and time again, this is just not the case. And just this morning, in a conversation with Lex Van Geen, who introduced me to Lumetallix, it is just clear as day. As I tell him things, he just shrugs his shoulders. And I'm shrugging my shoulders right back to him. the fact that I remained more offended by him than he got of me just indicates, I guess, apparently his overall ability to cognate. I doubt he'll watch this, but when he does see this, right? Am I right? So anyway, I've kind of, gotten over my hang up here. And as I start to roll out more information on this topic, I will be sure to do it in a shorter format because 45 minutes is way too long. But this argument likely won't escalate because I do believe that when I press submit, which is going to be right now. Sorry, I just had to attach it. But yeah, so I think we're good here. Next. Yeah, so after I send this, I'll be done with this. This video basically serves as the complete overview of the invalidity of the patent. If it has to be argued later, probably just hire a lawyer, kick this to them, and let them take care of it. They know the procedure is much better than me. When I go to court, I tend to just say, hey, you know that the case law specifically forbids you from agreeing with these people? And I come off so strong that it's offensive. And so this is a pretty good go here. I think that this is definitely sufficient to, really intimate to the examiner that they're not going to be able to ignore the guidelines or act like they don't understand anything about, the hold this paper. And, it's going to be really difficult. I mean, the caliber at which the Lumetallix representative has been arguing is really, I mean, he doesn't have very much to work with, but saying that it's a relatively high concentration in a porous controlled system specifically developed for lead detection, it's just not a cogent argument. And they say the concentration may be very low, but he neglects to state anything about what they actually disclose or what they've actually been testing, and then just draws these conclusions. I was shocked that the examiner was just yeah, sure. They just didn't feel like arguing anymore. But and they actually said that they were going to allow the patent to be put through. But then what had happened was they kind of went back on that. And so I'm actually going to look this up. I'm so curious about what this means. Okay, yeah. So it looks like because they have it saying, because they already had right, intention to grant, right? And then I submitted, or somebody submitted some observations here. And then 2 different observations or something, multiple observations. And now, right here, on the 17th, they say that information on the status of an EP patent application or granted EP patent. And it says the status is now in progress. So originally it was intent to grant. And then they kind of let it run. But then all of a sudden it became disregard the intention to grant. We're still looking at this. So they're going to look at it further. I definitely want to continue working. And I'm going to submit these applications, get out of here. But I'm glad that I got over this one. So this is impossible to come over. If anybody can overcome these objections in the comment section, I'll give you $1,000 and then I'll donate 1,000 fluorospects to whoever you want. So try your best. Read the complaint, read the patent. All the stuff is in there. And I'll put the links in the description to this YouTube video and let me know what you think, because it's just impossible to overcome. So here we go. Submit observations. And then we can just kind of not worry about this anymore. And by we, I mean me. Download this. Date is Jan 9. And I'll see you on the next one. This isn't the funnest videos that I make, or this is a terribly annoying topic. I'd rather be doing something fun, but you know, my soul has just been so dragged down by the negativity surrounding this that I'm finding it hard to work. So thanks for watching, and I'll see you soon. It's Everything Lead.